talk about what it means to be a degree. We've already did this in the past, but we'll kind of recall some information here. The degree of the polynomial is the largest exponent. Largest exponent. So we're going to do some examples and figure out what the degree is. Because if you can figure out the degree, you can figure out the horizontal asymptotes pretty easily. So what is the degree of number 1? What is the largest exponent you see? 3. I'm going to circle it. 3 is your answer here. What about number 2? What's the largest exponent you see? 4. Okay, so 4. What about the next one?
2.
Number 4. Careful. 1. There's a 1 secretly here, so 1 is going to be my largest degree. What about 5?
5.
Very good. Now this one. Let's see if anyone can get this one. None or 0. Good. So 0. There is no x's there. So I'll maybe put a little star there if you didn't see it. There are no x's. If there's no x's, there's 0. Okay? Basically, you're counting out how many x's you can have as a max here. So your horizontal asymptote is going to be dependent on that degree. Okay? So a horizontal asymptote is the y value on your graph, which a function approaches but never touches. It's just like the vertical, but now we're going to be doing horizontal, which is this way. We've seen it on our graphs before, but we haven't talked about it. Okay, there are 3 conditions that you have to remember. The 3 conditions are as follows. So the first one is if the degree of the denominator is larger than the degree of the numerator, automatically your horizontal asymptotes at y equals 0. Like it's just a given. No matter what, y equals 0 is going to be your asymptote. So let's kind of go through that here. Actually, let me get you guys some highlighters. Sorry, I kind of threw that a little bit weird again, that one too. Oh, there you go, okay. All right, so your horizontal asymptote is going to be y equals 0. And I'm going to highlight this piece, y equals 0. And I'm also going to highlight right here, because that is y equals 0. And I'll write that in too. Y equals 0 is your horizontal asymptote, if you're asked. And let me explain it with the example. What is the degree of the top piece here? What is the degree of 1? Well, how many x's are there? 0. So the degree is 0. I'm going to put like a little 0 over here. What's the degree of the bottom? 1. And I'm going to highlight this piece too because that's what we're talking about. If the degree on the bottom is larger, it automatically is 0. So that's how you determine that. It's kind of like an interesting trick here. Let's do another one. Let's talk about this next condition. If the degrees are the same, okay, this is the only one that can get a little tricky, is if they're the same. You're going to take the ratio of the leading coefficient, so the number's all the way out in front. Okay, so let's take a look here. If you look here, what's the degree of the top? 2. What's the degree of the bottom? So I'm just kind of like going off to the side and writing that for myself. I mean, obviously you don't have to do that later on, but maybe for notes, kind of like write that in. Here's a degree. They're the same. So when they're the same, you have to do this ratio, and I'm going to highlight it for you. 6 divided by 2. Well, what is 6 divided by 2? 3. That is your horizontal asymptote. Y equals 3 in that situation. It's not always going to be 3, but in this situation, it's 3. And I'm going to highlight one more piece because look now at your graph. It's at y equals 3. Okay, you can see on the graph that that is true. Y equals 3 is your asymptote. You have to include the y because remember, vertical asymptotes are x's. Okay, so you got to be careful with those. Okay, now the last one I think is the easiest one. If the numerator is larger, then you have none, which I think is great. If you have none, awesome. There is nothing that you can highlight that there's no horizontal asymptote here. Okay, so let's talk about this as for the example. What's the degree of the top of this guy? 2. What about the bottom? 1. And if you see here, the degree of the top is higher than the bottom. And that's why there is no horizontal asymptote. And you can look at your graph. There's no like line that I can draw like this that like stops the graph. You can see that. Okay? That's it. That's the last thing you're learning this whole year. Literally this whole year, because then when we come back from break, it'll be 2019. Losing it. God, I can't believe we're getting to 2020. That's like soon. That's insane to me. Okay, now let's do some practice. Okay? Flip the page for me.
That means we graduate soon.
You are going to be graduating soon. You're almost there. You're closer to graduating than you were at the beginning of the year. It's awesome. Okay, first you need to figure out your degree. So what is the degree of the top?
1.
What's the degree of the bottom?
1.
So is it degree higher on the top, bottom, or the same? They are the same. Whenever it's the same, you have to do the ratio of the leading coefficient. So with my highlighter, I have the number out in front of here and the number out in front of here. Well, what number is out in front of the top?
1.
A 1. So y equals 1 over 2 is my horizontal asymptote, 1/2. If it divides, great. You could have used 0.5, but I'm just going to keep it a fraction. Now these things are coming back. This is from yesterday. But the best part about these is whatever your horizontal asymptote is your answer. Okay, so yesterday we talked about asymptotic behavior, so I want you guys to compare something with me. You guys look at this, keep your page there, and I'm going to scroll up to my other page. I want you guys to see the difference between the two. You see how there were infinities on your paper, and on my paper there are numbers. That they like flip on you is basically what's going to happen. When you're talking about the ends of a graph, they're going to be a number. When you're talking about, this part of this notation, they're going to be infinity signs now. So if you can compare between what you have on your paper and mine, they're basically going to flip. You're going to have a number as your answer here, but the infinities will be given to you. So this is called end behavior. This right here is called asymptote behavior. Because look, that's your asymptote. That's the ends because they're the infinity signs. Okay, so let's talk about this. So whatever your horizontal asymptote is going to be your end behavior. So guess what? 1/2 and 1/2. It's that simple. Maybe like draw an arrow, that's where it's coming from. Whatever, and I'll explain that when we get to the graph part. But it's kind of cool how mathematicians came up with these things. Like they're able to find the correlations between the function and the graph. Let's do it again. The first step in these problems when you're looking for your horizontal asymptote is to talk about the degrees. What's the degree of the top?
1.
What about the bottom?
2.
Which one's higher, the top or the bottom?
5.
So I'm going to highlight this bottom piece. Now when we go back to our chart on the previous page, the degree on the bottom means something. What automatically is your horizontal asymptote based off our chart? Careful. Degree of the denominator is larger. 0. Okay? So 0 is going to be automatically, it's just like given to you here. And I could explain to you like why that is if you're interested in like why would it be 0. Now like this is totally off topic. I just am a math person and I just like for you guys to understand like what you're doing. When you guys reduce something, like if I just gave you this, do you see how there would still be an x in the bottom? Like don't write this down. We're just going to kind of explore together so you understand. If you were to like reduce this, it would be 4 over x because there's 1 on top, 2 on bottom, 1's going to cancel. So remember what we talked about this whole chapter. What makes the bottom equal to 0? 0. Okay, so that's why it's going to be y equals 0 here. Okay, because you have something left on the bottom. Okay, it's kind of just something interesting for you to understand that that's the reason why. Okay, now let's talk about the next one. Oh, we're not done. So where do the ends go then? What number? 0. Done. And again, we'll talk about that more when we get to the graph of like why that is. Okay, what's the degree of the top here? And what about the bottom? Which one's bigger? The top. Okay, if the degree is higher in the top, what does our chart say happens? There is none. And when there is none, you can just cross off this piece. Because the ends are going to be going to like infinity and negative infinity, but we don't really care about that part. Okay, let's try it again. Let's keep going with it. What's the degree of the top? And what about the bottom? Is it higher on the top, bottom, or the same? Okay, if it's the same, we have to do the ratio. So that's literally what my thought process is. What's the degree of the top? What's the degree of the bottom? And if it's the same, then you have to do the ratio. So I'm going to highlight it. And I think someone was saying it, y equals 9 over 3, which is what? 3, and you're done. So your horizontal asymptote, that dotted line, is going to be y equals 3. Yeah. So you can just write y equals 3 if you knew that right away. Like if you, yeah, and then like your final answer would be y equals 3. Yeah. And if you like were on the test and you knew that you were dividing it and you didn't have to write this piece if you didn't want to, if you can see that right away. So then they both go to 3. Pretty straightforward. Okay. What's the degree of the top? And what about the bottom? Which one's higher? The 3 on the top. If the degree is higher on the top, what automatically is our asymptote? Careful. Say 1. We said none. The degree is higher in the numerator. It's none. You're right. Oh my God, I made an error. Pff, it's none. You're right. You're right. I was going in the same order as above. That's why. So none, yeah. If the degree is higher in the top, there is none. Let's do it one more time, just keeping the practice going. What's the degree of the top? Good. And the degree of the bottom? And which one's higher? Good. So what automatically is my asymptote? Very good. See, I think this is the easiest one. Yesterday and today were pretty straightforward. The hard parts were the foundations, the beginning of last week. Okay, now we're just going to put it all together. So this is everything that you've learned in this chapter, all in one problem. I told you this was coming. Okay, so now it's kind of cool that you're able to do all of the pieces here. So you guys are good at this when we break them down, but when we put them all together, we tend to like forget what we have to do. So let's just take our time. You will need a graphing calculator at some point, so if you didn't grab one, make sure you do. They're over here now if you have been gone for a while because someone tried to take one last week. So now they're by us. My calculator load here. Okay. So the very first thing it says is what's the factored form? That means we have to factor the top and factor the bottom if we can. Can we factor the top? No, there's nothing there that can pull out. There's no GCF, so we're good there. Now, the bottom piece can be factored. This was the square root one. Square root. I get x in what number? 2. So I have x plus 2 and x minus 2. So now that's the factored form. Then, this should say W-H-E-N. I can't spell. Okay? So, the discontinuities when x is what two numbers? Because look, there are two things right here, which means there are two discontinuities. What's one of them? Good, so I have plus 2 from this guy. And what's the other one? Minus 2. And if you got stuck, like where did we get that? You guys can set both of them equal to 0 and solve. So you could have done this. X plus 2 equals 0 and x minus 2 equals 0. It just depends on where you stand on knowing this stuff. If you know it pretty well, you can just flip the sign. If not, set them equal to 0 and solve. So now look, I have 2, which makes sense because there's supposed to be 2 right here. Now, here's a part where, again, people get confused. Like, well, I found the discontinuities. Now I got to go back and try to find the whole. I'm confused. You found these two pieces. Now you decide which one they are. So you either take this negative 2 and say, does this x plus 2 cancel with anything on top? Exactly. No. Did you have a question?
No.
Oh, you were like, so it does not cancel. So is it a whole or an asymptote? An asymptote. So x equals negative 2. Now we look at this guy. Here's the 2. So we were referring to this one. Does this x minus 2 cancel with anything on top? No. So it's also a vertical asymptote. So there are no holes. So you look at your discontinuities, and if they're both used here, then you have none, and vice versa. If this negative 2 was a hole and this one was a hole, then you'd have none there. Okay, so just taking those two discontinuities and putting them where they belong. If you count up these two, you should have the same amount. There's none here, 1, 2, 1, 2. Okay, you should be able to see that correlation here. Okay, so right away what my opinion is right when you find your hole or your asymptote, draw them in right away, just so that you don't forget to do that. So I'm going to draw in the -2 right here. X equals -2. And I'm also going to draw in the +2. That way, when I go to graph it, I don't forget to draw in my asymptotes and my holes. If there was a hole, we would also put that in, but we don't. Because that's the biggest thing that I see like on the test is that when you don't draw that in, you cross that line and you can't do that. That's the only part that you should really understand. Okay, so the domain is based off of your discontinuities. Where do I always start? Good, and then where am I going to go? To -2 or +2? Good, because it's always a smaller number first. And then -2 to where? 2, and then 2 to where? There we go. So you use both of those, and I can kind of highlight here. -2 went from here, and then here came these two. Okay, so you're always going to use those discontinuities here. And sometimes I like to highlight like all the way through just so you can see like that they all go together. You know, here's your -2, and here's your +2 here. Okay, the only new piece are these next two pieces. Let's figure out your horizontal. Horizontal is what we just learned. So go back to the very beginning. I'm going to kind of like write maybe right here off to the side so we don't forget, like horizontal asymptote. Again, you do not have to write all of this when you're doing your homework and stuff, but when you look back at the notes, you can kind of understand what we're doing. What's the degree of the top? And then what's the degree of the bottom? 2. Is it higher in the top, bottom, or the same? So we have to do the ratio. Okay, so the ratio part. So here I go with a different color. 3/1. Do you see that? 3/1. So my horizontal asymptote is y equals 3. Okay. Now guess what? The range, just like here, the domain was affected by the discontinuities. Your range is going to be affected by your horizontal asymptote. It's the same thing as the domain, guys. Same thing, but we're using the 3 now. I'm going to use an arrow here. We're using the 3. So -infinity to now, where do you think it's going to stop? 3. Wherever I stop is where I start, and I always end at positive. It's the same exact setup as domain, but now I'm using my horizontal. Here's why, because range is all about y's. Domain is all about x's, which these are. So with that, I want to draw one more thing in. I need to draw in my horizontal asymptote at y equals 3. So I'm going to draw that in green here. Y equals 3, because now we got to go the other direction. Here. Okay, so now we got a lot of dotted lines. That means that your graph, when you draw it out, you can't touch them. That's all that means. Now, based off of what we learned, where should both the ends go? What number? 3. You can kind of see in green they all go together. That 3 followed all the way through. Then it says sketch, and we're done with the whole year, which is kind of crazy. So get out your graphing calculators and let's practice this together. And then you are free. This whole chapter, the rest of it, the whole rest of the semester is just review for you guys. It's kind of exciting. Okay, go to y equals, clear it out, because you want to practice it yourselves. Press the alpha button, which is the green button, and then y equals, and that gets you your fraction, which is kind of nice. Okay, because otherwise it gets confusing. I would definitely graph your original one so you don't get confused, or if you made an error on your factoring. So I have 3x squared plus 8 all over x squared minus 4. Okay, and then go ahead and hit graph. And take a look at what happens here. You can look and see kind of if it matches the things that we just did. Look, it looks like it's not going to hit this -2 right here. It looks like it's not going to hit this +2 right here. It also looks like 1, 2, 3 like, you see how this line here, it kind of looks like the graph's approaching this 3. Okay, so that's a good way to check your answers. You know, someone yesterday was like, my graph doesn't match what I got, and we realized that, you know, their work was incorrect. They factored incorrectly because the graph was wrong on their calculator, okay, compared to their answers. So always use that to help you. We're just going to sketch it in then. So you can see here, it looks something like this in black. It looks something like this over here. And then it looks like something like this. But you can see like that this would belong here. You can't touch these lines. Same thing here. You can't touch these lines. It's like it's broken up into 3 separate pieces, which is kind of crazy. Okay? So when you do draw it out, like the left side would be here, the middle is going to be in between these two, and the right side, you can kind of see how it all goes together. Do you have any questions? Okay, so a lot of this is just realizing what to do. This whole thing that we just did is everything that you have learned this whole entire chapter, but in one problem. Okay? And that was the goal, was to get you there. Okay, so if you felt like somewhat okay with most of this, then you got like tomorrow, the next day, you got 2 days of reviewing with me, and then you test for 2 days.